Welcome Math 10C. This is Unit 2, Polynomials, Unit Review. The first concept we talked about is what the heck is a polynomial to begin with. So polynomials, instead of talking about what they are, how about what are they not? So polynomials are not expressions with variables under radical signs at this point. That's where it is. In higher levels of math, we will discuss what happens with those variables under root signs. As well, we talk about what else is not a polynomial. Any variable in the denominator of an expression. And lastly, any expression that has exponents, any expression that has an exponent that is a rational number. I.e. a fraction exponent. Now, we know they exist, we deal with them, but they don't get the special name of being called a polynomial. So in other words, polynomials are every other expression where you can have expression with variables that are not under radical signs, expressions with variables that are not in the denominator of any fraction, and also expressions where under on the exponent it is not a rational number. So your exponent is a 0 or higher, or it can also be an integer, it can be a negative number, but it cannot be a rational number, meaning a fraction or a decimal. Okay, moving on. How do we know what degree a polynomial is? Well, the way we tell degree, it is identified and named by the variable in any polynomial expression so degree is named by the variable in any polynomial expression that has the highest exponent. Example. 5 got 3x squared minus 4x. The x has a hidden 1. The higher exponent is a 2. So this one is a degree 2, which we actually call a quadratic. It has a special name. Another example, I could have 4y minus 3y squared plus 4y to the 4th power. Here, they're not written in the correct order. We're usually written in descending order from largest to smallest exponent. In this case, they're not, but again, we're looking for the highest exponent on the variable. So here we've got degree 4. Back to our first couple examples, when we were talking about what is not a polynomial, let's take a look at a couple of these examples. Could I have root x cubed under my radical sign. No, we would not call that a polynomial. Okay? For the simple fact the variable is under the root. We do deal with those later, but they're not given the polynomial name. They're called radicals. As well, what about this one? You'll notice this one has a variable in the denominator. So this is what's wrong with it, whereas this here, it was the radical sign. It couldn't be under a radical sign. Here it is the fact that the variable is in the denominator. So, moving on, another example, if we've got a fraction exponent, for example, that is similar to this, y squared minus 4y plus 7x minus 6w to the negative 1/3. Now, we already know from our radicals unit, yes, we can deal with negative fraction exponents, but they don't get the special name polynomial, okay? So this, because of that, that whole expression is not considered polynomial. So all three of those expressions are not polynomials. The next thing we talked about was adding and subtracting polynomials. When we add and subtract polynomials, we need to make sure they have the same base and same exponent. And if they do, we give them the special name of being called like terms. We can only ever add and subtract like terms. Example, 5x minus 3y plus 2z plus 4y minus 1z. In this example, the only things you can add together are the ones with the same variables. Same variable, same exponent on that variable. If you take a look at our variables, they all have a hidden exponent 1. So try and draw in those 1s so you don't forget they're there. Then take a look, and what you're going to do is you're going to group your like terms and add them together. Make sure you take that sign in front. That tells us whether it's a negative or positive. If you're dealing with algebra tiles, it would tell us whether it is a black or shaded or a white positive, depending on what the shading key they give you. Or, as we've done on the board before, green is positive, red is negative. Over here, same thing, but I've got a positive y. These y's can be added together because they have the same base, which is the variable y, and they have the same exponent, which is a 1. So, I can add those digits together. Now, what I would do is all you add together is the coefficients. Remember, coefficients are the digits in front of variables that are attached to the variable in front. So, in this case, the negative 3 is my coefficient. Over here, it'll be my positive 4 that is my coefficient. So in that case, I'm taking a negative 3 plusing 4. I'm going to get a positive 1y from adding those. Nothing adds to my poor little x here, so I'm going to bring him down. Don't forget to connect with positive or negative signs when you're connecting terms when you're creating an expression. This guy here has a hidden positive sign out front, which is why he needs to be separated by a positive sign. If there's a negative sign, they have to show you. But if it starts with a positive, they will not show you a positive sign. Next, we can actually take a look and group together the z's. So I'm going to have a 2z and a negative 1z. Those z's can be added together. Again, you have the coefficients. 2 plus a negative 1 is going to give me a positive 1z. That will be your final answer unless they specifically told you what x, y, and z would equal. Okay? So that's adding and subtracting polynomials. Let's take a look if we put some brackets in there. How does that change things? Okay, if we want to add and subtract polynomials with brackets, we need to first remember how to multiply. So if I've got a polynomial like this, 4x squared minus 2x plus 3 minus 7x squared plus 2x plus 3. If I want to add those polynomials together, I first have to distribute that negative sign into the bracket. They may put a bracket around your first expression, but really all it's there to do is to show you that it's a trinomial 3 terms. All right, you have a hidden -1 here. You're going to multiply it into the brackets. Essentially, all it does is it creates a pattern of reversing the signs. So a negative times your positive 7x squared is going to give you a negative x squared. So this comes down as a negative 7x squared. Going to the next one, my negative 7x, or sorry, my -1 multiplying by my 2x is going to give me a negative 2x. My negative multiplying again by a positive is going to give me a negative 3. I'm just going to write the expression before. They come down, 4x squared minus 2x plus 3. Now I can group my like terms and add them together. When you're going to group your like terms, again, find the ones with the same base and exponent. This one's got an x squared, same as this one. So x exponent 2 is the base with the correct exponent. So I'm going to add the digit 4 to my -7 here. So 4 and a -7 give me a negative 3x squared. I've dealt with the x squareds. Let's take a look now at the x's, x exponent 1. So I have a negative 2x exponent 1. Over here, I've got the identical thing, a negative 2x exponent 1. Remember, when you're adding them together, you do not add the exponents. The exponents stay the same. You just add the coefficients. So a -2 adding a -2 is going to give you a negative 4x exponent 1. Do you have to show the hiding 1 exponent? No, but you need to know he's there. Lastly, the 3 is going to add to the -3, which is going to give you a 0. So you do not have to add plus 0. You just have to basically eliminate the 3's, okay? They would cancel out. So we would end up with a resulting binomial answer, 2 terms, okay? Moving right along, let's take a look at multiplying and dividing. When we multiply polynomials, we're going to first take a look at the different types of multiplying. So for multiplying, the first thing with multiplying is we check and see if there's anything attached to a bracket. And that's usually where we use our distributive property. So the first one we're going to talk about is distributive property. Okay, and this is where you take the coefficient attached to the bracket and you multiply it, or the term, it could be an x as well, a variable. So you take the term outside, attached to the bracket, and you multiply it in, just like we're going to do here. If I've got a 5x to the 7, and I would like to multiply it to a negative 3x squared, a positive 4x exponent 6, and a negative 2w plus a 6z squared. All right, that's a large polynomial. It doesn't matter how big we make them, we're going to use the same process. We first take a look, there's my first term. I'm going to multiply it into the bracket. I'll give you a moment to take a look and start writing that down. Okay, so once we take a look, we're going to do our very first term. We're going to multiply the 5 to the -3 because we deal with coefficients first. It's going to give us a negative 15. Then we deal with the variables. They're the same variable, so all we're going to do is add their exponents because we're multiplying. So we're going to have x exponent 9 when we add the 7 and the 2. Okay? The next term, we're going to multiply the 5x exponent 7 to the 4x exponent 6. The 5 is going to multiply by the 4 to give us a positive 20. The x's are the same variables, so we can add their exponents. So we're going to get x exponent 13. The next one down the line, I've got a negative 2w. So the 5 is going to multiply by the negative 2 to give us a negative 10. But now I've got two different variables. They are different, so you cannot add their exponents. Yes, the w has a hidden 1, but you're not going to write x8w. All you do is you take the two letters, the two variables, and you sit them side by side beside your 10. And yes, they usually go alphabetical. So x7 would come first, and then w with his hidden 1 next. Lastly, we're going to multiply the 5x7 out front to our 6z squared at the back. That's going to give us a 5 times 6 will give us a positive 30. Our z and our x again, just like our w and x, are different variables, which means we just have to stack them side by side. Again, alphabetically, so x will come first, x7, and then z squared. That will be your final answer. Again, unless they tell you exactly what x, w, and z are equal to, so you can solve them. So that's an example of distributive property. Now we're going to take a look at distributive property when there's more than one attached out front. Typically, it'll be a binomial in a bracket. So let's take a look at multiplying binomials. So that'll be the second one, multiplying binomials. And there's multiple different ways we can do it. We can use algebra tiles. We can use, we'll call algebra tiles A. B, we can use FOIL. And lastly, the area diagram, which we so fondly in class call the box. Okay, the box method. Okay, so the area diagram, same thing as the area box. So here's my example, and I'm going to do it exactly all three ways for you. I'll give you a moment to write those ways down. Okay, algebra tiles. Here's my example. I'm going to have x minus 3 multiplying by x plus 2. We're going to say that shaded is negative and that white is positive. So what I do is I create what's called a little bit of a T-chart. And I'm now going to start drawing my algebra tile. So how I do that, an algebra tile, the x is a long, skinny stick sort of thing. So what we do, I've got one x, so I'm going to draw a long stick for my x, and then I've got negative 3. So I've got 3 individual units at the end, which are all shaded. Those are my negative 3. On the next term, I've got x plus 2. So x is going to go on the side, and I've got a plus 2, two positive constants. So when we multiply them using an area diagram, you take one of the terms and it goes on top. You draw their algebra tiles. Now he could have went on top or on the side. It really doesn't matter. So if you put them on the side, the other one goes on the top and vice versa. So now what we do is we create the lines that have created those. So the lines that create division, meaning the division between the objects. So these ones, we're going to slice through the diagram, slice through your diagram. Now we're going to slice down where we see the separations. You slice down continually until you finish, and you erase what's left over. Okay? So now we've created our algebra tile diagram. We need to label what we've created. We have found 1x squared, 1 negative x, so this guy is shaded, another negative x shaded, another negative x shaded, a positive x and a positive x, and then I'm going to get some shaded constants. So if I wanted to write my full answer, I need to add the ones that are identical but opposite colors. They could almost be same color. It really doesn't matter if they're all positives or all negatives, but you need to add the ones that are like terms. So you would add all the x squareds together, you're going to add the x's together and the constants together. So we only have 1x squared, so our answer would be 1x squared. I've got 1, 2, so 2 positive x's. They're going to cancel out 2 of my negative x's, so those don't belong anymore. I'm left over with a negative 1x. And then I've got these baby 6's here. I've got negative 6 constant. So our final answer is going to be 1x squared minus 1x minus 6. So that's using algebra tiles. Let's try it now the other way. Okay, now we've got the same equation, or the same expression, pardon me, and we're going to solve it 2 different ways. First way we're going to solve it now, FOIL, the second way I should say, and then the next way we're going to solve it is using the area diagram, the box. So if we FOIL, the letters F-O-I-L actually stand for something. The F stands for the first term in each bracket. So that's these two. So you're going to get x times x. Now remember, when we multiply variables, we add the exponents of like variables. So the ones that are the same letter, the x's, the same letter, same variable, we're going to add their exponents. That's going to give us x squared. Then we're going to take our O. Our O means our outside terms. That's these two. We're going to get x and positive 2. Now by outside it means which ones are on the ends of the expression. So this would be the front end, this would be the back end of the complete expression. So that's why it's outside to outside. They're the outer edges of our equation, of our expression. So that's going to give me a 2x. Then we take the inside. The inside are these two. We're going to have a negative 3 timesing by x to give us a negative 3x. Then we do our very last one, which is the L. L is the last term in each bracket. So we're going to get negative 3 timesing by 2 to give us our negative 6. You're going to notice that in most situations, the O and the I are usually like terms that we can add once we're done multiplying. So we can actually add those now to get our final answer, which we already know is x squared minus 1x minus 6. Okay, so we get the exact same answer using a different strategy. Now we're going to use the area diagram. I'll give you a minute to write that down. Push pause now and play when you're ready. Okay, using the area diagram, we're going to basically create a box, a window. So we're going to create a window that's got exactly the same amount of terms as it does. So here's our box. Okay. And on the left-hand side, like we did with the algebra tiles, we put one of our terms. So I'm going to put the x minus 3 down here. And on top, I'm going to put the x plus 2. And just like FOIL, we multiply in to fill out each box or each square in our box. So when I multiply x by x, I'm going to get x squared. X by 2, 2x. Next, I'm going to multiply negative 3 times x to give me a negative 3x. And negative 3 times 2 to give me a negative 6. In your area diagrams, these boxes, you're going to notice as well, just like FOIL, 2 of them are going to add to create a like term, typically. In this case, it's going to be your diagonals. So we have a negative 3 and a positive 2, which is going to give us our negative 1. So we've got x squared minus 1x minus 6. And that's multiplying in a nutshell. The only thing we do is we add a few things to this multiply. We make it a little bit more complicated by adding a few things to this. So here's another example. We're going to have 3 in front of x plus 2, 2x minus 7. In this case, there's 2 ways you could do this question. You could do the multiplying first, like we use with the algebra tiles, area diagram, or FOIL, and then lastly distribute the 3 to every term in our answer. Or, secondly, we could multiply the 3 into the first set of brackets, not both sets, and then multiply that answer by the other bracket. So that is the other strategy. Solve it the way you would. I like to use BEDMAS, which most of you should be using as BEDMAS, and we're going to solve the brackets first, which means we need to multiply these. I like the area box. I'm going to use an area box. My first term's on top. I'm going to put my x plus 2 on the side and my 2x minus 7 on the top. You're going to notice I put my plus in front and my negative in front. You need to add those signs in there. So when you're multiplying, you know whether you're multiplying positives and negatives. With this question, we're going to get 2x squared, negative 7x, 4x, and a negative 14. Now, you don't need to draw all those arrows. I'm just showing you where I'm getting the answers to fill in the box. And again, I check for like terms, same base exponents. That is going to be my x to the 1, which is going to be diagonal again. So my final answer is going to give me 2x squared minus 3x minus 14. Now, don't forget, we're not quite done. We still have this dangling 3 out front. So now we've got to deal with that 3. We're going to take the answer we created, and we're going to multiply the 3 into it. So we're going to have a 3 on the outside of bracket, 2x squared minus 3x minus 14 on the inside of the bracket. Now we're going to multiply the 3 into the bracket. 6x squared minus 9x minus 42. Okay? Make sure you check your work. So that's one other strategy where they could create things a little bit more difficult for you. We're going to take a look at 2 more. So looking in the review pages, one of the questions that you're going to see are these. You're going to see they use t, but I'm going to use x. X minus 5 and x squared plus 2x plus 4. Now this question, again, you're using a binomial times a trinomial. In these cases, you can't use FOIL. You have too many arrows to deal with. So, well, you could, but it complicates things and you might forget a step. So to avoid forgetting a step, use the area box and just create a 2x3 window. Now we're ready to multiply. My x and my negative 5 go on the left, my x squared, 2x, and 4 go on top. And again, I multiply. Don't forget the hidden ones on your variables. I've got a 1 there and a 1 there. So my answer inside my boxes are going to become x cubed, 2x squared, 4x, negative 5x squared, negative 10x, and negative 20. Again, once I've filled in my area box, I'm looking for like terms. So I circle my like terms that are diagonal, and I add them together. And again, when you're adding like terms, you're only adding coefficients. You don't add the variables. So my final answer is going to be x cubed, negative 3x squared, negative 6x minus 20. The only other way that they can make this a little bit more difficult are for the next couple situations. As you see on letter C, you've got x minus 3 and x minus 1 squared. Well, don't let that little squared sign fool you. All it's telling you is you've got 2 of those sets of brackets. So try to use a habit of erasing the 2 and drawing the extra set of bracket. That way, hopefully you won't remember to multiply it. A lot of people start multiplying the 2 in the bracket. You can't do that. Okay? You're having a subtraction separating the terms, which means you can't use the exponent laws there. So in this case, you can start multiplying anywhere. I could start multiplying these get my answer, then multiply by my x minus 1, or I could do the opposite and multiply the back 2, get my answer, and multiply it by the front term. So whichever you prefer. And the only other situation you're going to see from that is where they complicate things with adding 2 or 3 more things. You could see where they've got y plus 4 squared, or sorry, cubed, which means you've got 3 sets of those brackets. Okay, so they could complicate it by doing that for you. You could also get a situation where you've got a trinomial times a trinomial. And we get lots of area and perimeter questions where we have to use our area and our perimeter, where we have to add and multiply. Okay, so that is multiplying in a nutshell. Now we're going to take a quick look at factoring. So instead of dividing, we don't divide, we factor. So factoring is a fancy way of saying you're going to be dividing some polynomials and breaking them up. So what we're doing is we're actually trying to find out what we started with. It is reversing FOIL, or reversing the area diagram. We're given the answer. We want to find out what the brackets were that we started with. For example, if we take a look at the first one, the first type we have is greatest common factor. So if we take a look at number 11a, we've got 4y squared minus 8y cubed plus 4y exponent 4. We need to create and find a greatest common factor. Now, what the heck is a greatest common factor? Your greatest common factor is a digit that will multiply out of each of your coefficients, and a variable if it shows up in each expression, each term. So we have a y with each term. Now we take out the lowest number of y's, so whichever the lowest exponent is. So my lowest exponent is a 2, so I can divide out y squared. Now I take a look at 4, 8, and 4, and they can all divide by 2, but 4 is even larger. You take your largest, which is why it's called greatest. So we're going to divide out 4y squared. Now once we find our GCF, we don't leave it. He actually has to be attached to our question. So what we're going, to our answer. So when we check our answer, if we multiply it back through, we get what we started with. So in this case, I'm going to take my 4y squared. It's going to go on the outside of a bracket. These brackets you're opening up are going to be the answer of what the division is. So make a habit of putting your greatest common factor under each term. Then it's easier to deal with. So if I take a look at 4 and 4, 4 divides by 4 once, y squared and y squared cancel. I've got nothing left for that specific situation, so you must show the place value of a 1. Okay, because it was one whole term that was canceled. Over here, we've got a negative 8 dividing by 4 to give me a negative 2 for a coefficient. Now you look at your variables. Because we're dividing, we can subtract like variables. I'm going to get y exponent 1. The very last term, my 4's can cancel, but my y's I still have to subtract. I'm going to get positive y squared. Now, why did I put the positive sign there? Because you've got to separate terms with positive and negative signs. Here is a positive. I took a positive and divided by a positive, so I had to connect this term with a plus sign. Now I'm going to close my bracket, and that is my final answer. If you want to check your work at this point, all you do is you redistribute what you took out. So you would take your greatest common factor and you would multiply it to each term. Now this is why we need to have a place value holder for that number 1 there. That 1 is telling us that if I multiply that 4y squared in, it's going to go where that 1 is. Because 1 times 4y squared is 4y squared. If I didn't have that 1 there, I would get an answer with only 2 things. 2 different terms. I didn't start with just 2 different terms, I started with 3 different terms. So that's why it's important to make sure that you have that 1 placeholder. Then we deal with group factoring. If you take a look at letter C is dealing with group factoring. We've got 5r squared s cubed bracket r plus 3 minus 4rs squared bracket r plus 3. So what we're going to do here is we're going to take a look. The hard work's been done for us. They've taken the GCFs out. So each of these that I'm going to circle were the GCFs that were divided out initially to create the common factor of what we ended up with, which is our r plus 3. Whenever we group factor, we want to have one term that's identical to the other. So we find that the identical term, we only have to bring down and write it once. So I'm going to have an r plus 3. But the ones that started the multiplication, started the division and the factoring, that we did factor out to begin with, these must go in a bracket separately. They're going to attach either out front or at the back, my 5r squared s cubed and my negative 4rs squared are going to go in my bracket. This is my final answer. I can't go any further. And that's pulling things in from group factoring. Lastly, we're going to have factoring trinomials. And there's a couple different types of trinomials. We're going to have trinomials that we need to do the diamond method with, and trinomials that we don't. So let's take a look first. If we look at number 12, the first thing we always have to do first, whenever we look at any situation for factoring, is always see if you can take a GCF out first. Always, always. And if you can, that's where you start. On number 12a, I can take everything out by a 3. I can divide 3 from each of those digits. I will be left with a squared minus 4ab plus 4b squared. Now I need to diamond factor that. So when I diamond factor, the top number is the a times c number. Well, that's not from what we started with initially. It's from what we end up with in brackets after we've taken the GCF out. Our 3 is our GCF. So our a times c, I'm going to take 1 times 4 to give me 4. My middle term is my b term on the bottom. It's going to give me a negative 4. So what multiplies to 4 and adds to 4 gives us a negative 2. So negative 2 and negative 2. If we've got a hidden 1 in front of our a squared or x squared or whatever variable squared it is that we're factoring, if we've got a hidden 1 in front, we do not have to divide the wings. The wings are what we created here, the sides of our diamond. We initially would divide them by a 1, but does dividing by 1 change their answer? No, it doesn't. Once we have a different number in front of a squared, then that step is what we need to do first before we put it into our brackets. So we're going to factor now. We've just finished factoring. We're going to now create our 2 brackets. We've created our 2 brackets. Our original GCF, the 3 that we took out, has to slide in front and go in front of our first bracket. I take a look and see what variable it is that I've used. I've used an A. It's going to start both brackets. I take a look at the back. I have a variable at the back. So it's going to be at the end of each bracket. Then I take a look and I look at my wings. I've got a negative 2 and a negative 2. Those are going to go in front of my B's to fill in the rest of my brackets. Now you've created your terms. If you want to check your work, you factor in, area box, FOIL, diamond method, whichever, and then multiply the 3 in last. That'll give you what you started with. So that's the first type of situation we have for trinomials. The second situation we have for trinomials are going to be where we don't have, or where we do have a number in front. If we take a look at letter E, we've got 2x squared plus 7x plus 3. Now we've got a digit in front of x squared, whereas before, after we took our GCF out, we did not. We had a hidden 1. The minute we've got a number out front, we call that the A factor. Okay? We need to factor that A number. So we need to know what are the 2 numbers that multiply to give us a 2. Well, the only 2 numbers are 2 and 1. So I open my 2 brackets to start, And one will start with a 2x, the other one will start with a 1x. Now I start my diamond. A times C on top, B is on the bottom. When I take a look here, my A number is my 2, my B number is a 7, my C number is a 3. So A times C will give me a 6, my B number is a 7. What multiplies to 6 and adds to 7 is 6 and 1. This is our special step. Now I look at my wings, and I look at the factors of A that I put in my brackets. Now I need to divide these wing numbers by one of those numbers. You always divide by where you're not going to get a result of a fraction or decimal. So if I took the 1 and divided by the 2, I would get a fraction, which is why I'm not going to divide the 1 by the 2. I'm going to divide the 6 by the 2 and the 1 by the 1. Once I now want to put my answer at the back of my brackets, I need to make sure that when I do that, the one I divided by, the number I divided by, the answer of dividing cannot go in the same bracket as that 2 where it came from. So this answer 3 is going to go in the other bracket, positive 3. On the other side over here, we've got a positive 1. It's just going to be divided by 1, which gives us a 1. It will go in the bracket that it didn't divide by. It didn't divide by a 2. It's in the 2 bracket. So that's diamond factoring when you got to factor A. There's other complicated situations where you're going to have different factors of A where you're going to have to take a look. And it's on your diamond where you see which ones it'll multiply by. For example, if you've got a 12x squared as your front, you're not going to be sure whether or not you've got 12 and 1 to start your brackets. You don't know if you've got a 6x and a 2x or a 3x and a 4x. The way you figure out which ones you start with is what the rest of the polynomial is when you factor it and what you get your wings. When you're on your wings, that's where you decide what actually starts your bracket. Does your wings divide evenly without decimals by the 12 and the 1? If so, you would use that set. If it doesn't, you would try the next one, 6 and 2, and so on. So basically, you factor the letter A, okay, that factor of A, that coefficient. And that is factoring. The last thing we need to look at now for factoring is difference of squares factoring. Difference of squares factoring means that two of them, and there's two terms for difference of squares, and they are able to be square rooted. Example, you have a difference of squares on number 19, page 7. You've got x squared minus 225. So if you take 225 and you square root it, let's take a look and see what answer you get. You're going to get a 15. So you know it's possible then to square root both. The fact is it's got to be a subtraction sign between them. If it was this situation, x squared plus 225, this is not factorable. It must be a difference of squares, meaning a subtraction sign in the middle, to use this rule. So you would square root each term, open your two brackets. X squared, when you square root it, becomes an x and an x. They go in the first part, first spot in each bracket. The 225, when you square root it, gave you a 15. And now, in order to get your minus sign in the middle, you need to separate each of those with opposite signs. One will be a positive, one will be a negative. Does it matter which one is which? No, it does not. Sometimes you're going to have a question where you've got a number in front where both numbers can be square rooted. For example, letter B, you've got 169x squared minus 196y squared. Well, in this case, we check our square roots. Yes, they are both perfect squares. So I can open two brackets. The square root of 169 is 13. And then I put my x with that. take a look and I'm going to square root 196. And I'm going to get 14. And we notice there's a y square attached, so we're going to put a y after each 14. And again, our last step, because it's a difference of squares, in order to get a negative answer, we need to have opposite signs. So we put a positive in one bracket and a negative in the other bracket. The other questions are for you to practice. That is Unit 2, Polynomials.